Okay guys, let's take a look at this problem. I've changed some of the numbers. It may be impossible. We'll see what comes up. So find the displacement versus time graph of the following scenario. So let's just do that and we'll come back to everything else later. Okay, so then we're going to do that and blah 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 blah. Those are the things to do now. Okay. So Abby wants to go to Bob's house 40 meters away. Now notice this is different than what is in yours. Stop. Okay, 40 meters away. This is different than yours, but okay, whatever. To study for the physics quiz. She starts from rest. That's extremely important. She starts from rest. Very important. You should get what that means by now, I hope. From her house and accelerates for 6 seconds. And in that 6 seconds, she travels a total of 7 meters. Now let's call this is a story, guys. Now every story starts at a point, and it starts at point A. And let's say it ends up at point B. Okay? So once again, this line right here, this one line, is a story. Starts at A, ends at B. Okay? Now, this next part of the story is a continuation of the overall story, but a story in and of itself. Now, just like every day ends with the beginning of a new day, this is going to be B, and this is going to be C, and this is going to be D, and this, sorry, I made my own mistake. This is going to be C, and this is going to be D, and this is going to be D, and this is going to be E, and this is going to be E, and this is going to be F. And we'll see how well this works out. Now, once again, guys, this is what I'm trying to stress here, is that this is the beginning overall of our story, and it goes to point B. But then, right after point B, another story begins. But that story begins where the other story left off. So if you'll notice, guys, this B corresponds to this B, and this C corresponds to this C, and this D corresponds to this D, and this E corresponds to this E. Now guys, the main thing I'm trying to stress is this is one story, but you can break it into its parts. You can break it into its components, each of which being its own little sub-story. Okay. So here we go. Now I am just simply going to do my drawing. So let's look at my first drawing, and that's drawing AB, and I'm going to do it right here. Control Z. Now guys, once again, a lot of this stuff you're only going to get from practice, so the main thing I can stress, guys, is doing your homework and practicing. So AB. Now if we look once again, going back to our group graphing exercise, we know she starts from rest and accelerates for 6 seconds and ends up 7 meters away. So let's label our axes. Now guys, each axis is going to be labeled a little differently. I know it's going to be annoying, but you'll complain, but you'll get over it. So here we go. Here's where she starts off. She starts off at the origin at rest, 0, 0. And let's make this 2, 4, 6, 8. And let's make this 2, 4, 6, 8. Now guys, this is just for the story part AB. It's not the whole thing. And once again, when we look at this, for A, she starts at rest, she goes for 6 seconds, and ends up 7 meters. So once again, she goes for 6 seconds. Here is 6 seconds. Here is 7 meters. So where these two intersect, that's her point. Okay? She goes from here, ends up here. How does she get there? Well, that's where you have to look at the section once again, the excerpt. Look, it says she accelerates. So it means from here to here, and I can label these. This is what I was talking about. This is going to be point B, and this is going to be point A. To get from A to B, she doesn't go a straight line. She doesn't do this. No, she does not do that. That's for uniform motion. She does uniform acceleration. So let's draw that. Now we have two different options of how this is going to look. It could either look like this. Either look like this, go up and curve this way, or it can look like this. It can curve up like so. So which way does it do? Well, what we have to do is you have to zoom in at this very beginning. And notice when we look back at this, it says she starts from rest. So which one of these starts closest to 0? Well, if you look at it very carefully right here, if this is drawn properly, it starts off this one going perfectly horizontal. This is once again, the velocity of this graph is the slope. And that's something you definitely must note, that the velocity of this graph is slope. This is the graph. This is it. If she had an initial velocity of something and had a final velocity of 0, it'd be this one. But because it says VI equals to 0, we're going to go with this one. So let's just delete this guy. Now, once again, remember, guys, this is extremely important. If you don't know this by now, you really need to be looking over your notes. Slope of this graph equals velocity. Okay, we've done the first part. Let's go to the second part. Now, the second part, remember, guys, is going to be, now I'll write it over here to the side. Second part is going to be BC. Okay. B says she then jogged at a steady pace of 4 meters per second for 10 seconds. Okay. Now, here's what we're going to do. We know that she goes at a pace or a velocity equal to 4 meters per second for a time of 10 seconds. Now, the thing to look at is this. Velocity will be the slope. Again, that's very important that we realize this now. But the other thing that we have is distance on this axis. Now, we can't just use the slope to find the distance. We'll have to use the time. And we'll use this formula. This is a constant velocity, so we can use this formula. I must stress, guys, only use this formula for constant velocity. Please, if this does not make sense to you, well, if you don't know this, write this down now. This is only for constant velocities. This formula right here is only for constant velocities. So anytime you hear acceleration, you can't use this formula. Okay. So let's just treat this the same way. Let's make this axis, whatever, 2, 4, 6, 8, 10. Okay. And this one we're going to have to treat a little differently, because when we calculate our d, we're going to get d equals v times t. And when we plug everything in, we're going to go 4 times 10 is going to give me a d equal to 40. Now, everybody's going to complain about this, but I'm not going to use the same scale that I used up here, because obviously I can't fit. So here we go. 10, 20, 30, 40. And this graph is going to be a straight line. I'm going to just draw it because, well, I guess I'll use I'll use a vector. Just ignore the fact that it's a vector, guys. It's not supposed to be one, but up, Control Z. It's going, that's ugly. Let's do this. So it's going to end here at this point, and it's going to be a straight line. That's a pretty good straight line. Straight line. From there to there. Straight line. It's a straight line because of constant velocity. Okay. And once again, if we want to label our points, let's go, this is going to be C, and this is going to be point B. Okay? Alright, well, we've got BC done. Let's move on to CD. CD. She came to an abrupt stop with Jane for 10 seconds. Chat, whatever. Who cares? For 10 seconds. Now, during this time, she doesn't move at all. I'll just keep this the same way. Sorry for not labeling my axes. I'm trying to be in a hurry to get this done, but you guys should know that this is my time axis. Didn't do it in the last one either. Sorry. I'm trying to get this done. And the distance axis doesn't matter at all because she doesn't really move. So let's just say that this one's going to look like this. That is not what it looks like, Mr. Shaw. It looks like this. And this is point C, and this is point D. Okay, easy enough. Now, let's move on to DE. Now notice, guys, what I'm doing. I'm really doing my best to make this problem as easy as possible by making it into little pieces. So once again, when we're at DE, Jane reminds Abby that a calculator would be helpful for the quiz. So Abby ran back to her house at a steady rate of 4 meters per second to get her calculator. Okay, now here's the main thing. This one is tricky. Now the reason this is tricky is because it doesn't, so far we've been only saying that these things have been positive velocities. This has been a positive velocity. This acceleration has been positive. Everything's been positive. But now she's going in the opposite direction that she was traveling entirely initially. So because this is the case, that she's going back to where she came from, we're going to have to make this value negative. And you'll have to realize this. And this, once again, guys, comes from practice, practice, practice. So I'm going to start off up here at 0. You'll be like, what? But you'll see in a second. And she ran back home. This is going to be tough. Let's wait. We can't solve this one yet. Let's do some other things. So let's look at the things we've already solved. I know. Mr. Shaw, you're running away from your own strategy. I know. I am. But we'll get back to it. Don't worry, guys. So what I'm going to do, guys, is I'm going to start to graph the whole thing. So the first thing I want to do is I want a really big graph for this. So I'm going to get out a really big graph. And here coming is one really big graph. There we go. And this is my big D versus T graph, guys. Please don't get on me for not labeling my axis on the other video, or the earlier in the video. And we have T. And so far, this may be difficult and annoying, but we'll get it done. We've went for a total 6 seconds this one, 10 seconds this one, and 10 seconds this one. So that's going to put us at a total of 28 seconds. Now we're not all the way done. We're not all the way done. Once again, from C to D we went 10 seconds. From B to C we went 10 seconds, and from A to B we went 6 seconds. So we're not all the way done. We still have not done D to E and E to F, but we've gotten the first 3 done. Now, why am I stopping here? Because she's got to run home next, and we haven't established how far from home she's traveled totally, so I'm going to do that now.